Mechatronics Department, K.S.Rangasamy College of Technology, Tiruchendur. LVDT. LVDT is the linear variable differential transducers or transformer. It is an electromechanical transducer coupled to any type of object or structure. Convert the rectilinear motion of an object into corresponding electrical signal. It measures the displacement. Precisions of LVDT, movements as small as few millionth of an inch. Usually measurements are taken on the order plus or minus 12 inch. Some of the LVDT capability to measure up to 20-inch measurement. It is used for linear and rotary displacement. It is, if we are measure the rotary displacement, it is called as rotary variable differential transducers or transformers. LVDT, it figure shows it is a construction view of LVDT. It consists basically two primary winding and two secondary windings wound over the hollow tube and positioned as a primary winding is between two secondary winding. It is shows in the construction view of the LVDT. The first figure shows the one primary winding in between the core is placed. The secondary winding is split into two equal number of turns. It is the secondary induced EMF in secondary S1 minus S2. If the core is in null position, that is S1 equal to S2, therefore no output will be produced. In the core moves based on the positive or negative directions. The difference between the S1 and S2 stored in the gives the displacement of the displacement in electrical signals. LVDT iron core side with two tubes, therefore affects the magnet coupling between the primary and the two secondaries. When the core is in center, the voltage induced in two secondaries are equal. I already told the in core is in center position, the output produced is same. And core moves based on the direction that the deflection will takes place. It is a linear, the output in phase outpace the core position. Based on the core position, it is a linear movement. The core position, it is a linear range of output will be produced in LVDT. So why use of LVDT? It is a friction-free operation. No mechanical contact between core and coil usually. Infinite mechanical life. Infinite solutions, electromagnetic coupling, limited only electrical noise, low risk of damage. Most of the LVDTs have open bore holes, null point repeatability, zero displacement can be measured, single axis sensitivity, effect of other axis are not felt on the axis of interest. Environmentally rugged, stable, strong sensor, good structural engineering test. So based on these, we can use as a LVDT for displacement measurement. First thing is a friction-free operation. Applications of LVDT, automotive or automation machineries, civil structural engineering, power generations, manufacturers, metal stamping and foaming, OEM, pulp and papers, industrial valves, R&D and testing, automotive racing. These are the applications of LVDT. Applications, civil structural engineering examples. Displacement measurement is embedded concrete test for tensile compression, bending strength, and a crack growth concrete. Deformation and grip of concrete wall used for retaining wall in large gas pipe installation. Dynamic measurements of fatigue and large structural component used in suspension bridge. Downhole applications, measuring displacement, bed cracks, etc. These are some of the applications of Lvdt. Types of Lvdt. Lvdt can be classified into DC and AC operation. In DC operation, age of installation, simpler data conditioning, operation from dry cell batteries, low system cost. AC operated, smaller than DC, more accurate than DC, operate well as high temperature. These are some type of Lvdts. Unguided armature, first thing. Second thing, captive armature. Third one, spring extended armature. See the spring armature with standard ball tips, captive armature with optional spherical bearings, unguided armature with threaded tips. We already see the construction view of Lvdt. I already told us it has one primary winding and the two secondary windings, that is split into equal number of turns. That is primary winding. Between the primary winding and the secondary winding, the core is placed. It acts as a transformer action. Primary induced EMF is in secondary. If core is in null position, secondary winding is equal number of turns, S1 and S2 is equal to the core is moves both the direction. The deflection in ES1 and ES2 changes. The change in ES1 and ES2 as a displacement. In terms of displacement, it gives a milliwatt output. Second is RVDT. It is a primary winding and the secondary windings construction. Advantages of Lvdt. The output of Lvdt is displacement up to 5 mm. The change in output voltage is continuous stepless, high output, low hysterics. These are the basic things of Lvdt. Thank you for watching. Keep learning and growing.